Hello everyone. Today I will introduce the assignment 3, query-centric PageRank. And PageRank is one of the most well-known algorithms for graph mining, and also is very useful for information retrieval. And in this assignment, you need to finish two tasks. And both of the tasks are related to PageRank algorithm. The task 1 is to rank the authors in scholarly database. It's just a simple PageRank algorithm. And the task 2 is to rank the authors given a query. It's a PageRank algorithm with prior. So there's a little bit different there. And in order to finish these two tasks, we offer you two extra datasets. The first one is a graph dataset. It's stored in a PageNet format, and it's about each node in the graph is the author and the relationship, the ages between the authors are citation. So you can regard it as a scholarly database. And the Lucene index is all the related information for the authors so that you can make a profile for each author. And first, let's take a look at task 1. And for the implementation, remember you need to use a GUNG package here. And here I offer you a web page for the documentation. And to implement the code, you need to set up a dumping factor. And in our assignment, I want you to set it as 0.15. And you just need to implement, basically, you just need to use this Java class and load the graph dataset in memory, and then run this. The PageRank class offer you a very straightforward function to calculate each node's PageRank score. So it should be quite easy for you. And I will introduce the skeleton code later on. And in the end, you need to finish all your code in a author rank.java file and list the top 10 ranked authors. Report it to me. And the task 2 is rank the authors given a query. This time, in task 1, all the author nodes are equal in the beginning. But here, we have some prior knowledge. For example, we want to know who are those most important authors in a particular domain, such as information retrieval. So here, we have some prior knowledge for each authors. And in this condition, all the authors have different prior scores. And we need to figure out a way to calculate all the prior scores for each author. And this time, we need to use the Lucene index. The Lucene index has 4 different fields for each document. It contains paper ID, paper content, author ID, and author name. And author ID are mapping to the node ID on the graph, so you can find out, given author ID, you can find out where he is located in the graph and what are the papers he published. And a thing need to mention here is that the index is generated by Lucene version 4.10. Remember for the previous assignment we used Lucene version 6, so this time you need to convert to this Lucene because the dataset offered to you is a little bit old. And in order to load the index, you can check the Lucene documentations online. They are basically the same, although the versions are different. And to calculate the author's prior scores given a query, the first you need to do is send the query to the Lucene index and find the top ranked 300 publications using BM25 algorithm. You just need to compare the query with the paper content field for each document and retrieve the top ranked 300 papers from the Lucene index. And for the second step, for the all retrieved papers, you need to get the ranking score and add the ranking score to the related authors as a prior probability. For example, if an author published 3 papers in the in the retrieved 300 publications, and the 3 papers has a ranking score as 0.1, 0.05, and 0.05. So in the end, the related author can have a prior score as the sum of them, so it should be 0.2. And in the end, we need to normalize all the authors' prior scores so that all the prior scores are summed up to 1. And in the end, the authors have different prior scores on the graph, and you need to use the PageRank with prior class to generate the PageRank score for each authors with their priors. And you need to implement the code in author rank with query.java, and you need to list the top 10 ranked authors given for the given query data mining, and another top 10 ranked authors for the given query information retrieval. And for the skeleton code, I will offer and introduce later on. So don't worry about the assignment.